Hello everyone, I'd like to welcome you all to this new series on how to build your very own Linux distribution absolutely from scratch. So, during this series, we'll compile Linux kernel, BusyBox, set up networking, and manage the bootloader so that our system would be capable of booting on both the legacy BIOS and the modern UEFI as well. But before we start, let me demonstrate how the end result of this particular Linux distribution we're supposed to be developing is going to look like. So I'm currently within the distribution itself. I call it Monkey See, Monkey Do Linux, just like the name of the channel. So here is the project structure. We have the config, distribution, init, and source folders. Image just contains the screenshot for the operating system. So yeah, first let me just go and run it, and then we'll talk in details in regards to how this actually works. So I just cd into the source, and here I have the running term shell script, which allows me to use the ncurses interface to render things instead of the standard SDL, I guess, based QEMU. All right, so we've just connected to the network, and although this is the emulated network of QEMU, it still works on the real hardware. So we just booted to the operating system. So let me show what is in here. So this is the basic structure. We are within the so-called init ramfs territory, which means that the root file system lives entirely within the RAM. All right, so probably let's get started with, well, apart from BusyBox, at the current state, it has two essential tools. One is the text editor that I've written on my very own called VICI. So let me demonstrate you this. And I will open the init file, which is the initializations. So this is the very first file to be called by the kernel. So it starts with suppressing kernel messages because I do not want to pollute the shell when I'm loading. Then I mount dev.tempfs in order to populate the dev folder with like tty0123 console and a lot of other things. Mounting the proc file system, the sysfs, so all this are required by the kernel. Here we have a simple loop that loops over the network devices, and it also calls the network shell located within the ads directory to turn the certain network device up. And finally, we use the has-been init as the PID1. So PID1 is special in Linux. You cannot sort of kill it. You cannot exit because otherwise kernel would panic. So this has-been init, we're giving control to has-been init from this particular script in order to manage events like reboot, power off requests, etc. So let's now have a look at the network shell first, and then at the inittab, which is the file, which is the configuration file for the has-been init. Right. So I am going to the ads directory. So here we have the network shell. So let me open this one. So again, like this script is called by the udhcp, and you see these environmental variables like IP, mask, and interface. So udhcp creates the corresponding environmental variables with this particular values, so that when we boot, we do see like which IP did we obtain, what's the mask, and what's the router. So hopefully this makes sense. And after this script is being called, what we have as a result, we have, so to just say if config, and to be exact, if config eth0. So we have here like IP address 10.02.15. Again, this is the emulated because of the QEMU itself. On the real hardware, this is going to be like 192.168.11 or 120 or whatever, depending on your local network settings. It also prints the mask, all the stuff. So in order to have this working, we need to activate the network devices. Once this is done, we can then use the ping command. So for instance, I will now ping the Google DNS server, and I do get bytes, which proves that network indeed sort of exists. And you see, like, we had received packages 742. Okay, and if I just call it again, now we have 2276. So yeah, it really proves that the network is actually working. But there is a very interesting issue that is arising because of the statically linked system. So I have the BusyBox being statically linked, and because of that, there is no such an application as widget. I just disable this within the BusyBox configuration during the install. And the reason for that is because widget actually does rely on the libnss underscore DNS which is the dynamically linked library, shared object sort of thing. And since we're having the statically linked system, that's not an option. Well, you could have used the .a equivalent of the same library, but yeah, that's a little bit complicated. Well, it's not complicated. I just didn't really want that. So I came up with quite an interesting workaround. I've created my very own widget alternative in Go with a custom DNS resolver, and also it drops the certificates. So just doesn't care about certificates. Well, probably a bit compromising in regards to security, but yeah, when did I care about security for the last time? Never, probably. So just want to give you an idea how get is actually working. So if I say get and let's say https and let's say example.com, I'll go in HTTP GET request, and here is the response. And for instance, I can also redirect this to a file. Just before that, I also promised to show the init tab. Yeah, because so let me show you the init tab first. So init tab, this is the configuration file for the has been init. So when the system initializes, I clear the screen and I bring the logo to the screen, that monkey that you've seen on start. On restart, we call has been init again in order to avoid kernel panicking. On shutdown, we just unmount everything if it's available. On Control Alt Del Delete, it's the same as reboot. And every time respawn happens, we call this bin shell. So hopefully this all makes sense. Okay, now let's drop back to the get. So just escape from here and let me just create a folder. So mkdir tmp. Yeah, I should have added this to the root file system so that when ISO boots, so it's already there because that's the standard folder. Well, I will do this later. No, I didn't yet have time for doing this. But anyway, so let's cd into the temp. Nothing here. So let's say I can say get https and example.com. So if I just run it, it brings the output to the standard output. But I can redirect this to files. So I can call it example.html. Okay. And now we have the file. Now we can open this file with the text editor and inspect what is in there. So this is the HTML response from calling the example.com domain. Yeah. Okay, so this actually proves that we can not only observe the content of certain web pages, but we can also download files. And this arises quite an interesting options and opportunity. So let me demonstrate you that as well. So there is a nice project called Static Get by minus that's the minus Min OS, or I'm not quite sure how that is called. So that's the sort of operating system project. So the idea is that that project has the statically linked binaries. Like, say you want to install Vim, but you cannot install dynamically linked Vim because the system does not support dynamically linked libraries. So you need to do what you need to build Vim on your very own, just and make sure that the resulting binary would be statically linked. But say you do not want to do this, you can use the existing one. So let me just demonstrate. So if I say get and HTTPS, so there is a static get shell script, but I didn't install it here. I didn't use it because it relies either on wget or CURL. But since those do rely on libnss_DNS, this is not an option of this system. This is not simply going to work. However, using this get that I've provided, it's still possible to sort of manually download the tarball and then manually extract it and manually install all the steps. Essentially, like the same functionality, but done a little bit more manual. But still can be optimized if I would have provided my very own script. But yeah, since any RAMFS is like living entirely in the RAM, it doesn't make sense to install anything in here because when you reboot, the changes would get lost. If only you just mount the hard drive and you just can write things to the hard drive. I'm on the emulator now, although in QEMU it's also possible to mount the hard drive, but yeah, so it doesn't make sense. But on the real hardware, it actually does. So I can mount my SSD drive and I can do some work and store the changes to the drive and be happy with that. So let's simply say get and HTTP, no, not HTTPS, but HTTP, and s dot minus dot io slash archive, like this. And yes, here we have the list of the mirrors. So let's use the one called Bifrost, or Bifrost, not quite sure how that is spelled properly. So Bifrost, and that's what is there. So we need the x86-64, x86-64. Okay, and here we have a whole lot of packages available for download. So let's say before searching for a package, we need to make sure that it actually exists there. So I can use grab to search for Vim, let's say. And here are the options for Vim. So now I can do the following thing. I can download the Vim tar GZ, for instance. So I can say here Vim -7.3-1 tar.gz, and I want to store it to the file, download it to the file called vim.tar.gz. Okay, now it downloads. Okay, it takes time. Okay, ls. So we have our vim.tar.gz. Now let's say mkd vim and cd to the vim, and now let's extract. So tar minus x vf and one level up vim tar gz, and we do extract things. So here we have the user folder, go into the user, and we have bin, so go into bin, and here we have the vim binary executables, all the statical links. So let's say I run vim, for instance. Okay, and we have just installed Vim on this operating system, which is cool. So can it do something? Well, I obviously prefer my very own text editor, and well, Vim is like classics and definitely much better than my editor, but much bigger as well, way more complicated in terms of learning curve. So anyway, let's just quit from here for now. Let's say I want to reboot the system and it handles this properly, and the Grub Bootloader is being activated. I'm sorry for rendering, a bit sucks. That's because of the emulator. I'm not quite sure what exactly that is happening, but yeah. Okay. And again, note that it would now get the IP address, right? So yeah, and let's now power off. So I will now go back to my original system. So now let's have a look at the project structure. Well, although the way we're supposed to be doing this is going to have a little bit different structure for the sake of clarity and simplicity. But anyway, I just want to demonstrate how this particular one that is being used within the repos actually looks like. So let's go to CFG. So this one contains all the configuration files. So BusyBox configuration, kernel configuration, the Grub configuration. So let's kickstart with the Grub configuration. This is the smallest and the most simple and straightforward. By the way, when you will be remastering the ISO, that is also an option. I'll now demonstrate how that can be done. You can change the resolution here. So instead of setting GFX mod auto, you can say like equals to 1024 768 32, for instance. And well, on QEMU there's not going to change, but the real hardware it does. So if you want to make letters a bit bigger, that's something that you can use. Right. Also, yeah. So whatever you change within the Grub CFG, when you remaster the ISO, the changes are being applied. Then let's have a look at the BusyBox. So here, the notable things is the statical link. Config static equals to yes. So build options. I want to have the BusyBox being statically linked. This is quite important. And also, I did disable widget due to the reasons, widget is not set, and all this has been disabled due to the reasons I've been describing, like those regards to libnss underscore DNS. So because we don't have that sort of a feature, we just disable widgets. So yeah, we just don't need to use get instead. All right, and finally, if we go to kernel CFG, so here some essential things to have a look at is the UEFI settings. So say EFI, and so EFI support is yes, EFI stub is yes, and EFI mixed also yes. So this is quite important. And also the frame buffer. It's called Visa frame buffer. If I'm not mistaken. Nope. Well, just a frame buffer. Yeah. Frame buffer. Well, actually, hold on a second. That's called graphics, if I'm not mistaken. Yeah, graphics support. Yeah. So this is it, and those essential options. Well, I don't see the frame buffer, to be honest. Where's my frame buffer? Yeah, here are they. So this is quite essential. So the frame buffer command line. This is very important. Just the frame buffer is equal to yes, because well, it took me really long to make sure that on the real hardware I actually have the like something on screen, because I've spent countless hours figuring out why I can't see the output in QEMU, but I don't see anything on the real hardware. So really spent lots of time to make sure that this config is actually good enough to work properly on my hardware. Hopefully this is going to be the case for your hardware as well. All right. So now let's go to so DST. Yes, go to DST. So here we have, here is the folder. DST stands for distro. So here we have the msmdlinux.iso living, and if you remaster it, it would also live here. I will now go to remastering, just bear with me. And the ISO folder is used indeed in order to provide that sort of files to remaster. So essentially, ISO consists of three parts: the Linux kernel, you see this BZ image file, the root cpio.gz, which is the compressed root file system, and the Grub Bootloader. Under the Grub folder, we have the Grub config, which has been copied from the up-level config directory. So it gets updated here every time you create a new ISO. So hopefully that makes sense. Now, this root cpio.gz can indeed be altered, and now we are going to that in particular. So I go to source. So let's go step by step. So starting with the build call. So this is the script to build Monkey See, Monkey Do Linux distribution from scratch. So it sets up the versions for Kernel and BusyBox, installs all the dependencies to be able to actually compile it. Then there's some cleanup, creates the build folder in particular, where all the files would be downloaded and installed under that directory. So go into build, downloading kernel, extracting kernel, go into the kernel folder, configuring kernel. When the def config is made, we then do copy the specific kernel configuration from the config folder. Then we compile kernel using all the available cores of the CPU. Then we do exactly the same steps for the BusyBox. And then we build the root file system. So creating the root folder. Then the BusyBox was installed into the BusyBox uppercase folder. So we use that as a basis because that provides all the files for the BusyBox itself. We are going in there. We get rid of Linux RC because we're using init ramfs and not the init rd. And Linux RC is needed for init rd, so we don't need this. We just get rid of that. Then we do create some additional folders, dev, proc, and sys to make sure the kernel works properly, so it should populate this. So you remember we've been mounting the dev.tembfs, procfs, and sysfs in the init. So here we copy the init from the init directory, also inittab, to make sure that has been init has the configuration file. Yeah, I forgot to show the contents of the init file. I will now show you that. Logo is just this cute logo with monkey on the screen, and that work shell does yeah, I've been actually showing you this under the system itself. Yeah, and then it just creates the ISO file. So what it does, it just copies the kernel to the boot folder under the ISO, copies the root cpio.gz, copies the grub configuration to the grub folder, and then just creates the ISO. That's pretty much all about it. So again, one last time. So go into init folder. So here are the files. So if say you want to change the init, you can change it here. So say VICI init. Yes, you can change it, and then if you like build it from scratch, this would get result. Well, probably I should have had the option to be able to change the init when you just remaster the ISO, because you don't quite really need to like recompile the kernel every time. Yeah, it's another good idea for an improvement. Again, finally, let's go to source and well, burn shell. Burn shell. Be careful with this script because it's specific to my particular system. Because when I plug in the USB flash drive, it becomes SDA 1, 2, 3, 4. But since I don't really want to write into partition, but into just the device itself, I use just SD without specifying like 1, 2, 3 or whatever. But on your system, this might not be dev SDA, this might be dev SDB or whatever. Use sudo fdisk-l to figure out your particular USB device. Hopefully that makes sense as well. Now, run and running term shells are just those storing the command to run QEMU. And finally, the most interesting, so VICI install packages. So here, this is quite an interesting script. So what it does the following thing. So just make some preparations, creates the packages folder, goes there, then it downloads those packages we're interested in. So in particular, I'm downloading my get, which is the wget alternative, and the VICI, which is the text editor. Then creating the root file, the root folder, and then I unpack the existing root CPIO GZ from the ISO boot, and I do copy the packages that I've downloaded to the specific folders, to the user bin in particular in this case. Well, you can manipulate and alter the root FS in whatever way you would like, because, well, it's still relevant. Once you are done with populating the rootfs with either newly installed packages or whatever changes you want to make, you then pack it back, and it does replace the one that has been there under the ISO boot folder, so it just gets replaced. And then again, it just copies the grub configuration. Here I also need to add the line to copy the init, because you might want to change the init as well. And finally, it just creates the ISO again with this newly updated root file system. Okay, guys, so I think this is kind of it. So we are supposed to be doing the following steps within this tutorial series. So let me just go to build core again. So all the steps been presented here, I will be covering those in separate videos, giving more details on every single step in particular, starting from building the kernel. Make sure that all the required configurations are set up. Then there would be a separate video on building BusyBox, then the separate video on building the root file system. Then there would be a video on, just go up here. There would be the video on how to make okay, how to make this init script. So init, to make sure that we can do all the necessary work and to make networking so working. And also, we'll run the script, the network shell, the script. We'll write this one as well, so we'll explain in details what this does in particular. So this is going to be fun, I hope. And then I have plans to install some development environment. Well, in particular, I'm now playing around with installing the statically linked Go programming language, Golang, to this system, and it seems quite promising so far. So we would be able to write Go programs. We won't be that easy with like dynamic packages download, but if you have the pre-installed packages in the system, then you can develop, and that's quite good. So guys, this is in regards to the intro and to the demonstration of the Monkey See Monkey Do Linux distribution. So I hope you enjoyed the video. Thanks for watching, and I'll see you in the next tutorial.